Given that f of x is e to the x minus 2 and g of x is log x plus 3, find f of g of x and state its domain and range. So, composite function, if we start with x, we can see the first thing that happens is it goes into the function g. X goes in this way. So, x is going to go to ln x plus 3. And that is then going to go into the f function. So that is e to the ln x plus 3, take away 2. So f of g of x is going to be e to the ln x plus 1, which is e to the ln x times e to the 1. And e to the ln x is just x, so it's ex. Now, y equals ex is a straight line, but that doesn't necessarily mean, so y equals ex would be like this, it will have a gradient of e, but that doesn't mean that the domain can be all values like it would be for the line y equals ex, because we remember that we were putting the values into this function, and this function cannot take 0 or any negative values. So we have to have x is a real, x is greater than 0 for the domain. And that means that the line can only really go from here upwards, which means that the range is going to be y is a real, y is greater than 0. We now want to find g of f of x and state its domain and range. So this time we're going into f first. So, starting with x, we'll get e to the x minus 2, and we're going to put that into the log. So we get ln e to the x minus 2 plus 3. So that is going to be x minus 2 ln e plus 3. Ln e is 1, so y equals x minus 2 plus 3. Y is going to be x plus 1. So that is our g of f of x is x plus 1. Now in this instance, there is no problem at all putting any value at all into e to the x minus 2. It will take all real values. So the domain is going to be x belongs to the reals, and that's it, all real values. That being the case, it's going to be the whole of the line y equals x plus 1, which means y is all reals.